Hello and welcome to week 9 of cit225. Still Brother Stevic, still teaching the class. Guys doing great. Week 8, actually just finished grading everything that was turned in. Everyone was pretty solid. There were a couple, the only mistakes that really were there is a number of you had a problem with the sequence for the price table, but other than that, everything was swimming. So keep up that great work. Keep up everything you're doing. We got, what is it, like 6 weeks left? 5 weeks left. So it's easy sailing from here. Labs 9 and 10 get a little complicated. I'm going to do the Lab 9 video right now, and not that you'll know in a few minutes when I'm done with this, I'm doing Lab 10. So I'm going to knock them both out tonight. Because they're both pretty much doing the same thing. There's not a lot of demos I can do on it because of what the labs are asking you to do. 11 and 12 get into this merge command, a couple of interesting, and 13 and 14, labs 13 and 14, I've always done as an optional opportunity for extra credit because they deal with something called the LAMP stack. And the LAMP stack is basically publishing an application from start to finish. So 13 and 14 are optional. The final exam is not optional. However, you must take the final exam. People have asked that before when I said week 14 work was optional. It is just the lab that is optional. This also gives everyone a chance to make up any missing work they have from earlier in the semester, make up those quizzes. There's been not a lot of you have been doing the quizzes. I suggest that you do them. They're easy money. They're quick points. So I strongly suggest that you do them. If you haven't done one and want to do it, let me know. I will open it up for you so you can get it done. Other than that, I'll leave them as is. It's a quick 6 points. I mean, it's 14 weeks, 6 points each. That's 84 points you can earn there. That's like almost two labs. So consider getting those done because they will count against you if you don't do them. There are zeros. So, all right, let me go ahead and share my screen and let us talk about Lab 9. All right, here we go, Lab 9. 4 steps in Lab 9, 3, very simple, 4. The fourth one is actually simple, but you have to do what's being asked of you in the way it's being asked of you. Okay, so you'll see. Step 1, create the following transaction table as per the specifications, but do so understand the business logic of the model. After creating the transaction table, create a unique index on the columns that make up the natural key and call it the natural key index. So I don't know if we ever talked about what a natural key is, but if we haven't, let me quickly address what it is. A natural key is whatever columns in the table would be naturally searched for. For example, if you were in a customer table, the columns that would naturally be searched are last name, obviously, because no one searches by first name. That'd be silly. Phone number, maybe address, maybe zip code. Those would fall into the natural keys. So they're asking you to make an index on what they would consider to be the natural keys. Okay. Create the transaction table and the transaction S1 sequence as qualified below. Here's the business rule. Now, business rules, this is the first time we'll talk about those. Business rules are what the business, the customer, or they call the shareholder is the term that is in vogue now. It's what the shareholder wants to see done, why they're asking for it to be done. Okay. You may enter an account number into the transaction account column of 111 111 111 111 for a debit and 222 222 222 222 for a credit card. A debit recognizes payment for a rental and its value is a value that adds to the company's assets. A credit recognizes a refund for a rental, and the value that recognizes decrease the company's assets. Debits should have transaction type that maps to the corresponding debit row of the common lookup table, and credits should have the transaction type that matches. Okay. So basically, the business rule here is that if it's a debit, money coming in, we want it marked as such based on a row in the common lookup table. If it's a credit, we want it marked as a credit. It's a P&L statement, profit and loss statement. So they want to know what money's coming in versus what money's not coming in or going back out to the customer. Okay, so In the future, refinement of the pilot design. Okay, the system logic. In the future refinement of our pilot design, the transaction account column will be replaced by a foreign key that points to the chart of account table. A chart of account table holds rows that describe every account in its number. I know they've changed what these labs do, but I'm pretty sure that doesn't happen this semester. So if it does, it'll be in 12 or 13, 11 or 12. I know it doesn't happen in 9 or 10. I think it doesn't happen. I know it doesn't happen in 10. I don't think it may happen in 11 or 12, but I'm not sure. Okay, we've got transaction ID, which is the primary key, integer with the maximum size. Transaction not null will be a string. Transaction type is going to be a foreign key to the common look table, referencing common lookup ID, integer maximum. Transaction date, transaction amount, rental ID, which is going to be a foreign key to the rental table. Payment method type, which will be a foreign key to the common lookup table. Payment account number, created by, which is a foreign key to the system user table. Creation date, last updated by, foreign key to the system user table, and last update. The transaction amount column uses a number data type, but the column may contain an integer or decimal value. So number just means any generic number. Integer specifically means nothing non-decimal, and then there's others for decimals, which number allows. Okay, so that should all be, don't forget the Oracle database, you'll need to provide an explicit transaction S1 sequence. The sequence should start with a default value of 1. So at this point in time, you guys should know what that means. Create that table with the constraints as requested, and a sequence with a default value of 1 that increases by 1. Create the natural key index. Unique index is qualified below. Rental ID, transaction type, transaction date, payment method type, payment account number, and transaction amount. So again, a unique index means all of these make one entry, and that one entry must be unique in this table. Rental ID 3 can happen 10,000 times, it doesn't difference, but these 6 columns must be unique, and the combination of them can only occur once in the entire table. Okay. Step 2. Insert the following 2 transaction type rows and the 4 payment method type rows in the common lookup table. They should have valid who audit column data. So again, writing 6 insert statements to put these values in. Easy stuff. It's the common lookup table. Okay, create the airport and account list tables as per the specification, but do so understand the business logic of the model. So let's see what we got here. Okay. Implementation note, the airport table has a filtered substring relationship to account numbers because the business model is evolving toward airport kiosks rather than stores. It's an interesting model. It's kind of like Redbox, but Redbox isn't in airports. The account list contains a set of pre-seeded values that may be consumed as a new customer enters into the video store application. Business rule. You must see the airport with any additional information that may be added to the model to support new customers. The city where the customer lives needs to be mapped to the nearest regional airport. All account number columns values must contain valid account numbers from the account list table. When an account number is assigned by a customer, you must indicate the system user ID linked to assigning the account number by consumed by column of the account list table and provide date of activity in the consumed by column. Okay. So basically it's just saying that the airport table has to have the information from any city a customer lives in or can rent in. System logic seeding procedures are provided in the lab to update all existing data in the model. So a seeding procedure, you don't have to write this, it's provided for you in the lab, like it says. Basically just fills the table with data that needs to be, and you'll have to copy it and paste it and put it into your, and run it. Let's go through the airport table real quick. Airport ID, it's a primary key. Airport code, airport city, state province, created by, and last updated by, same as usual. It's foreign key to system user with system user ID. I don't particularly, I think it says here who to do it by. I don't particularly care if you use DBA2 or sysadmin or whatever you want, just as long as it's referencing there. You need to create a unique natural key, NK airport index. for the airport table, you should create it with the following columns: airport code, airport city, and state province. Notice that airport ID is not in here because we won't be searching by airport ID, but we will search by these other 4 things. Okay. So you need to, yeah, okay. Step C, you need to see the airport table with at least 3 cities and any other you've used for inserted values in the contact table. So here they've got 1, 2, 3, 4, 5, 6. I suggest you put all 6 in. That's why they put them there. LAX, Los Angeles Airport, so on and so forth. You can read them. Okay. And then you're going to make the account list table. Here we go, account list ID, the primary key, account number, consumed date, consumed by, using system user, created by, system user table, last updated by, using the system user table, and everything else is just not known the data type that they need it to be. Again, making tables, you guys have done this 1,000 times by now, not a big deal. Okay. Don't forget to create an account list S1, and I think up here it said don't forget to create a airport S1. I think I want to make sure that that's there. Well, you need to create an airport. There's create an airport S1 sequence. So don't forget to create the airport S1 sequence, and you're going to create the account list sequence as well. Verify everything's there. Okay. You need to see the account list table. This would take more time than leveraging a stored procedure, but writing stored procedures from class is beyond scope. Therefore, you've been provided the stored procedure for the databases. Click on the setup script. So here is the script you need to run. Okay. Just take a quick look. Let's take a quick walk through this so you can kind of see what it's doing. We're creating a creating or replace a stored procedure. So a stored procedure, if it's not really been talked about before, I don't think we brought it up, but a stored procedure is code. So every time you execute a query in the engine, you write your select statement, whatever it is, that language you wrote is translated into machine code. And from that machine code, something called an explain plan is made. An explain plan is a written or graphic representation of how the engine is going to execute that query. It's beyond the scope of this course, just kind of letting you know. So in the engine, there's metadata that shows how the query is run, how the indexes are being hit, where the slowest, if there's a backup, somewhere where that backup's happening. A stored procedure is code that you've written that is parsed into machine language and saved as machine language on the computer, so on the engine. So it never has to be parsed again, meaning it never has to be translated to machine language again. And the explain plan that's made is a permanent thing, so it's always there, which is good and bad. That's for another course. So making stored procedures, if you have a process that needs to run a couple times in a row from the customer, you'll create a stored procedure. That means the code will run the exact same way every time. And most importantly, you won't get a performance hit because the data has already been parsed. It's already machine language. It doesn't have to do that every time. If you have ad hoc code running from a front-end application and hitting the back-end database, it has to be parsed every time. And it might not seem like 10 milliseconds is a big deal, but if 500 people are hitting that application at the same time and trying to run the same query, that's going to parse out to a lot of time spent trying to parse a query. Okay. So we got a begin statement here. We've got a for statement, and we're just saying for while I is in, select distinct airport code from airport loop. You're going to go through a loop. So it's just basically going to go through a loop and insert this information as many times as it is, just quick loop. And that's just going to seed the account list table, which is what you need. It's got some exceptions here, a rollback statement. Okay. Once that's done, you need to execute. So you've created the store procedure, you need to execute the store procedure. So you use the command execute seed account list, and then that will run. Make sure that before you run this, make sure that your sequence is made. and make sure your table is made. And then when you run this, you just copy and paste all this from here. Just copy and paste all this. Run that part only. It'll create the store procedure, and then execute the store procedure, and you're good. Okay. After you create the account list table and the seed account list procedure, you call the seed list procedure to populate the table. Like we said, just run that execute statement, and that should be what you see. In a prior lab, and in both the create and seed scripts, state, province, column values use a mix of U.S. postal code and state abbreviation for names. You need to update state, province values with their full state names, because subsequent seedings, the import program rely on full state province names. You need to update, so what you need to do is update address, set state province California, or state province equals CA. That's all you need to do. And for whatever state's there, I think Utah, New York, New Jersey, whatever's there, you make sure that that is changed to the full state name and not the abbreviation. You need to run the update member account procedure, and you need to call the update values for member account lists. So again, here's your setup script. You just need to grab this information. It's giving the script to you because creating store procedures is not part of this course. Just take all of this here, bring it over, run it. It will create a store procedure, and then you will run execute member accounts, and it will do what it needs to do. Okay. Right. Now, this is the last step, and this is where you need to see the other ones before we got used to the idea of copying code. And the previous labs had, the last couple steps had you copying code and running the code. So this will be the same thing, because in this one, you're going to create the following transaction upload table as per the specification, but do so understanding the business logic of the model as a big picture. Our video store just got consolidation of rentals from a store that's closed for our customers. You need to import the values and ensure that our source data agrees with their source data. For example, do all the customer names, addresses, account numbers match our data? If they do, the merge should go well, and the figures ultimately be incorrect. The merging won't happen until lab 11, I believe. Right now, we're just setting it up. So let's look what you have to do here. You're going to create the transaction upload table. Account number, first name. Notice there's no foreign keys in this at all, because this is loading in. So basically the premise is we've got a store that closed down. We need to bring all their rental information over into our store, and then we're going to merge it with our data so we have a consolidated record of the two stores, who's rented what. Okay. So basically we have a CSV file that we need to import into our database. And what you can do in Oracle is basically create the table and then point it to that external file and have that data be sucked in to the table and be available to you in the table, so you can query it against everything else, which is a really, really fun thing to do. I know fun is a relative word, but I enjoy it. Okay, so now here's what you need to do, and this is where it gets a little tricky. Okay. You are using the instructor provided Linux image, so you will have to do this. Before you create the transaction upload table, you need to create a physical and virtual directory. You should use the following physical path for the upload directory. So you're going to do that. Assuming you're working in an Oracle 11g XE instance, which you are, you just want to go through these steps here. You make the directory, you can add to it, and then you're going to run these two commands here. You're going to copy the CSV file to the directory. You're going to unzip it. Just basically just follow these instructions and you'll be fine. And make sure that the CSV, the transaction upload CSV, is in that directory because you're going to log into your SQL Plus command. You're going to, as the sysadmin, you're going to connect. You're going to create the directory within Oracle, so it can. You're going to create directory upload as that location. Grant read write on directory to upload to students. So when you're logged in student, you can do all the stuff that you need to read, write, and stuff. So now here is what you're doing. Okay, you're creating the table, transaction upload with all this information, and then you're going to use this code right here. Okay, I jumped back in here. So you've got two, I want to give 2 examples here. So you're going to just use this code to put over there. So what this is doing, it's saying go externally, look in the default directory, upload, which you just gave yourself access to a few seconds ago. And these are the parameters. If it's a bad file, you're going to make a file called transaction upload bad. So it's basically an error file. Discard file to let you know what happened, and a log file to give you all the details. Fields terminated by a comment, they're CSV files, so it has to be a comment. A comment limited. If this were piped limited or anything else limited, you'd put whatever was there. Optional fields enclosed by a single quote. So you might have, like, single quotes there, so they'll just know that drop the quotes, don't need them. Missing field values are null. That means if while they're inserting something isn't there, it can put a null value in instead. And the location is transaction upload CSV, and that's what this does. Okay, and then reject limit unlimited. So I've got this here. You've also got this code right here that says no bad file, no discard file, no log file. That's valid too. But so what this will do is this will create the table, okay, and it will point the table to the CSV file, and the data will not ever exist on the hard drive. It'll always exist on that CSV file, so that cannot move. Okay, and then that's it. That's the lab, and then you test it. So that's all you got to do. So that is lab 9. That is plus a little bit bonuses about, a little information about how store procedures are made, how store procedures get parsed in the background. Didn't go into deep dive into it, but it is a very interesting topic. So this is really one of the only labs you have that's a lot of copy and paste. So just make sure you hit all the steps. If you have any problems, let me know. Let the TA know. See you on Wednesday, or show up on the Wednesday night activity. So I guess we're good. So if there's anything else, please let me know. Good work, and see you guys later.